On the behalf of Government Engineering College Banswara, I Dr. Sunil Gadhwal welcomes you once again online video lecture classes. Today we are going to discuss about cracking. As in the previous class we had discussed about fixed bed catalytic cracking. Today we will discuss moving bed catalytic cracking. And the another name of this cracking is fluid bed catalytic cracking. So this is very important from the examination point of view and advanced for industrial purpose. As we know that catalysts are the dead things in organic material. So the question arises in our mind how the catalyst will move. It doesn't matter that the thing, those who don't have life, they cannot move from one place to another place. And the other name of this cracking is given fluid bed catalytic cracking. So how this name is justifying, we will discuss in this topic. So this method is also known as fluid bed catalytic cracking. In this method, catalyst is used in the form of fine powder. So what is happening here, as you can see in this diagram, this is the little bit improved diagram in comparison to fixed bed catalytic cracking. This part is same, only the thing is this part is changed in the diagram. Here we are having two chambers, while in the fixed bed catalytic cracking we are having one chamber where we are putting catalyst on a fixed bed. So here we have to take the catalyst in this hoopers which are having holes here, and this hoopers will mechanically rotate, and the catalyst in the form of fine powder will come out from the holes, and it will travel from the top of this column towards bottom of the column. So the non-living catalyst will move from upward to downwards. So that's why the name is given moving bed catalytic cracking. So as you can see that heavy oil is fed in this preheated chamber where the temperature is 425 to 450 degrees centigrade. So at this temperature the heavy oil will come out as a vapor phase, and in this vapor phase it will travel and it will come here, and from the hooper here we are fixing the catalyst. And as this hooper will start moving from the holes, the catalyst will fall down and it will move towards the bottom, but again in the bottom it will come here, and while traveling here from upward to downward it will come in contact with the vapors of the heavy oil, and the temperature of this column is maintained 500 degrees centigrade. So at 500 degrees centigrade temperature, absence of air, this vapor will come in contact with catalyst and cracked, and the cracked vapors will come out from this hooper. This is the one way hooper. So from it will enter in this fractional column, and as we had discussed previously that these columns are having around 200 meters of height. So as soon as the vapors will move towards upward, temperature will goes down. So here we will get tar, then heavy oil, then diesel, in between kerosene, diesel, petrol, and these are the hydrocarbons which are in gaseous state. They will come here, cool them, and again we will get gasoline plus some dissolved gases, and again with the help of stabilizer we will separate gaseous hydrocarbon and this gasoline. So Once this catalyst will move from upward to downward, and it will come in the bottom of this chamber, and with this outlet it will come down here, and this pipe is connected with the air blower, so air will blow because the catalyst during the cracking, as we know that carbon will deposit on catalyst surface, so that catalyst having carbon on surface will come down here, and we will blow air with pressure, then this catalyst will move in this another chamber. Here the temperature is 600 degree, much higher than this catalytic chamber, and the air also will pass in, so that deposited carbon will burn, and the flue gases will come out through this hooper, and the catalyst will regenerate, and it will settle down here, and again it will come in this outlet of preheated chamber, and again it will reach directly to in the second chamber. Then again from the upward to downward it will come, then the air will to give him a proper direction, it will reach in first chamber, then again it will come down, and again it will. So here no need to stop in between the process. The problem we are facing in fixed bed catalytic cracking, that after 8 to 10 hours we have to stop the process. So here no need to stop the process, continuously this will work. So why so in this process, when catalyst is moving from this hooper towards here, then entering in this chamber, then from this chamber to again in catalytic chamber, so that's why this is known as a moving fluid bed catalytic cracking or moving bed catalytic cracking. So this method is also known as fluid bed catalytic cracking. In this method, catalyst is used from the fine powder which flow down to the catalytic chamber or cracking chamber through a hooper. The catalyst get mixed with the heavy oil vapors and behave like a fluid which can be circulated in gas streams. In moving bed catalytic cracking, the feed oil is first passed through a preheated chamber. The vapor of the feed oil along with very finely powdered catalyst are then passed in a reactor which is maintained temperature of 500 degrees centigrade for catalytic cracking. The cracked oil vapors are then passed to the fractionatory column where heavy oil is separated. Diesel, kerosene, naphthalene, etc. The vapors are then passed through the cooler where gasoline condenses along with some gases. This is then sent to a stabilizer where the dissolved gases are removed and pure gasoline is recovered. So the advantage of catalytic cracking over thermal cracking. The first is the yield of petrol in catalytic cracking is higher because catalysts are selective in their action and therefore they permit the cracking of only the high boiling hydrocarbon. Second advantage, the quality of petrol produced in catalytic cracking is better. The cracked product contain more amount of aromatic hydrocarbon. Aromatic hydrocarbon are having better anti-knocking characteristics. Then isomerization of branch and hydrocarbon occur there. Thereby better quality of petrol is produced. The product contain a lower amount of undesirable sulfur organosulfur compounds because a major portion of its escape as H2S gas. During cracking, decomposition of aromatic hydrocarbon remove only the side chain because ring remains as such. The third advantage is A much lower pressure, about 1 to 5 kg per centimeter, is needed in the catalytic cracking, while in fixed bed catalytic cracking we need 100 kg per centimeter square. The cracking process can be easily controlled so that the desired product can be obtained, and the percentage of gum forming compounds is very low. So hoping that you would understood the topic very well. In the next class we will discuss reforming. Thank you.